Earth, our home, a tiny blue dot floating in the vast cosmic ocean. It is the place where every human has lived and every story has been told. This is where our journey begins. But as we zoom out beyond the atmosphere, past the moon, and beyond our familiar planet and the sun, we embark on an epic quest, a quest to grasp the true scale of our universe. As we leave Earth's embrace, the first marker on our cosmic journey is the moon, about 384,000 kilometers away. To put that distance into perspective, if you drove a car at 100 kilometers per hour, it would take over 160 days to reach it. From this lunar vantage point, Earth appears as a fragile sphere of blue and green, cradled in the black void of space. This sight brings our existence into humbling focus. This is Earth, as seen from the moon. As we continue outward, the next milestone is the Sun, lying approximately 1 astronomical unit from Earth, a distance of about 150 million kilometers. Light, traveling at the staggering speed of 300,000 kilometers per second, takes around 8 minutes and 20 seconds to reach Earth. If you were to travel this distance in a commercial jet flying at 900 kilometers per hour, it would take nearly 19 years. Even within our solar system, this immense distance is a stark reminder of the vastness of space. The Sun, a fiery behemoth, provides life-sustaining energy to our planet from this incredible distance. Venturing beyond our solar companion, we set our sights on Mars, our mysterious red neighbor. At its closest, Mars is about 54.6 million kilometers away, though that distance can stretch to 401 million kilometers when the two planets are on opposite sides of the Sun. Traveling to Mars at the speed of a commercial jet would take over 50 years, highlighting the immense challenges space exploration faces due to the ever-shifting distances and orbital dynamics. As we journey further to the edges of our solar system, we reach Neptune, the distant ice giant, located roughly 4.5 billion kilometers from Earth. Sunlight takes approximately 4 hours and 15 minutes to reach Neptune, revealing just how immense our solar system is. Launched in 1977, Voyager 1 symbolizes humanity's relentless curiosity and desire to explore beyond known boundaries. Having traveled over 22 billion kilometers from Earth, it is the farthest human-made object from our planet. In 1990, at the suggestion of Carl Sagan, Voyager 1 turned its camera back toward Earth, capturing the iconic pale blue image. From a distance of about 6 billion kilometers, Earth appeared as nothing more than a tiny, faint in the vastness of space. Sean poetically reflected on this image, emphasizing our responsibility to cherish and preserve our only home, a small speck in the immense universe. At the very edge of our solar system lies the Oort Cloud, a vast theoretical sphere of icy objects. This distant cloud is believed to extend up to a staggering 100,000 astronomical units from the Sun, about 1.9 light years. This distance is so immense that it's on the cusp of interstellar space. Scientists have identified the boundary of interstellar space as the heliopause, where the Sun's solar wind is halted by the interstellar medium. This is the point where the influence of our Sun ends and the vast realm of interstellar space begins. The Oort Cloud represents the final frontier of our solar system, a boundary zone where the Sun's influence fades and the cosmic journey into the galaxy truly begins. As we venture beyond the solar system, our next destination is Alpha Centauri, the closest star system to our Sun, located about 41.3 trillion kilometers away, roughly 276,000 astronomical units. At such vast distances, the astronomical unit, a convenient measure within our solar system, becomes less practical. Thus, astronomers use the light year, the distance light travels in 1 year, for interstellar measurements. Alpha Centauri is about 4.4 light years away from us. Given current space travel technology, a journey to Alpha Centauri seems nearly impossible. For instance, the Voyager spacecraft, traveling at around 17 kilometers per second, would take more than 70,000 years to reach this neighboring star system. This colossal distance underscores the vastness of space that separates the stars and highlights the enormous challenges of interstellar travel. Our journey now takes us to the grand scale of our home galaxy, the Milky Way. Spanning about 100,000 light years in diameter, this spiral galaxy is home to hundreds of billions of stars, each potentially hosting their own planetary systems. Within this immense structure lies a tiny sphere known as the human radio bubble, extending about 100 light years from Earth. This bubble represents the furthest extent of human influence in the cosmos, the reach of our radio and television broadcasts. Beyond this bubble, it's as though humanity never existed. Any civilizations in the vast majority of the galaxy would be unaware of our presence, since our signals haven't yet reached them. The scale of the Milky Way is so vast that our entire recorded history is but a whisper in the cosmic wind, undetectable beyond this small bubble. As we leave the Milky Way, we enter the almost incomprehensible realm of intergalactic space, where galaxies float like islands in the cosmic ocean, separated by unimaginable distances. Our galaxy is part of a small cosmic neighborhood known as the Local Group, a cluster of more than 50 galaxies spread across approximately 10 million light years. The Local Group is a diverse assembly, including not just spiral galaxies like the Milky Way and Andromeda, but also a multitude of smaller dwarf galaxies. The distances here are so vast that light from one end of the Local Group to the other would take 10 million years to traverse, a scale that dwarfs anything within our own galaxy and highlights the sheer vastness of the universe. The enormity of the universe is truly staggering. Intergalactic space is a silent expanse, a vast wilderness between the islands of galactic light. In this immense void, our galaxy, home to all of human history, is just a tiny speck among countless others, a single story in the grand cosmic library. As we extend our gaze beyond the Local Group, we encounter the colossal Virgo Supercluster, an immense collection of galaxy groups and clusters, including our own Local Group. This region of space spans about 110 million light years in diameter, 33 megaparsecs. The Virgo Supercluster is a titanic structure, home to thousands of galaxies from at least 100 galaxy groups and clusters, each containing myriad stars and planets. Journeying even further outward, we reach an even more staggering cosmic structure, the Laniakea Supercluster. This immense congregation of galaxies, which includes the Virgo Supercluster, stretches over 500 million light years and represents our galactic home on a grand scale. Lives up to its name. It contains the mass of 100 million billion suns and is a gravitational masterpiece, with galaxy clusters, superclusters, and countless celestial bodies bound together in a cosmic web of attraction and motion. At the heart of Laniakea lies the Great Attractor, a mysterious region of space that exerts a massive gravitational pull on the galaxies within this supercluster. In this vast expanse, our Milky Way, the Local Group, and even the Virgo Supercluster are mere components of this gigantic structure. Laniakea offers a profound perspective on our place in the universe, revealing that we are part of something far greater and more majestic than we can fully comprehend. As we approach the boundaries of our cosmic exploration, we encounter the limits of the observable universe, an astronomical marvel stretching about 93 billion light years in diameter. This raises a fascinating question. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in cosmic expansion. Since the Big Bang, the universe has been expanding, stretching space, and increasing the distances between celestial bodies. But what lies beyond the observable universe? This remains one of the greatest mysteries in cosmology. Some regions of space are expanding away from us faster than the speed of light, placing them forever out of our reach. As a result, the true size of the universe remains unknown and potentially infinite. The observable universe, vast as it is, may be just a tiny fragment of the entire cosmic expanse. We are left with the humbling realization that there may always be regions of space, entire galaxies, and wonders that we will never witness, as they recede endlessly into the depths of the ever-expanding universe.